With some clever node placement, it's easy to get some really cool effects using Blender's shader system. So I looked around and I realized that no one has made a video on this yet, maybe for a good reason. I realized that something like this might not get a lot of views, but I just decided someone had to do it. So I decided to take one for the team real quick and present to you all of the Blender material nodes explained as quickly as possible. I'm not sure how long this video is going to end up being, but it's going to be a good resource for you to just browse through. You can look in the description for links to the various node categories. Do keep in mind that this is going to be an overview of each of the nodes. I'm not going to be explaining each and every input parameter and output there is for each node. If you would like some more detailed descriptions of each node, I will be linking you the Blender documentation for the shader nodes in the description, as well as various other resources that will be mentioned throughout the video. And also keep in mind that this is going to be a little less of a humorous video. I wanted to specifically make this a resource that clarifies some of what the documentation says. So with that, please enjoy this resource. It took a stupid amount of time to make, so as always, a subscription or like is much appreciated. But all I can ask beyond that is that you take a look at some of my other content as well. Enjoy, everybody. The ambient occlusion node takes whatever ambient occlusion is being generated on the model and returns it either as color or black and white data. That means in cycles it should be working automatically, but in Eevee you're going to need to check the ambient occlusion box in the render properties settings for it to start. Samples control the resolution, inside basically treats it as if the model is inside out, only local means other objects won't affect the ambient occlusion, color gives it a tint, distance controls how far away other objects can be to be considered for occlusion, and the normal input allows you to use a normal map that will also be included in the ambient occlusion. The attribute node is a testing node that allows developers to use attributes of models that they haven't created a node for yet. Most of these attributes actually do have nodes now, but you can use it to input things such as normals, vertex colors, and UV maps just by typing in the name and output that as a color, vector, or black and white data. The camera data node returns data based on the camera, as you might expect. The view vector node shows you data based on the model relative to the camera's position. The view z depth displays a linear gradient based on how far away the camera is from that part of the object, and the view distance does the same thing except with a radial gradient instead. Fresnel is an algorithm that determines where light should be reflected and where it should be refracted off of an object. In my experience, it's most commonly used to mix two materials, and it can be used to great effect, as you can see here. Next is the geometry node. This one is a beast. The first output gives you the actual position of an object. The normal output will give you the normals of the object in world space, not local space. That's the difference. True normal is just like the normal output, except if your object is flat, it's still going to show that even if you've shaded your model smoothly. So back facing returns black for the backside of a face and white for the inside. Hair info does exactly what you might expect. It can tell you whether something is a strand, where the ray intercepts with the strand, the thickness of the strand, and even return a random value to maybe randomize the hair color and things like that. The layer weight node is similar to the Fresnel node, except it has a few more options. To start, we also have this facing output that is similar to Fresnel, except it has a more linear fall off. Additionally, it's much easier to work with when you're using a 0:1 scale instead of the alternative. If you're into tricking the renderer, the light path node is for you. Starting with the is camera ray, this will show you if what you're looking at is a direct view of the camera or a result of a reflection from another object. And this could be useful, let's say you wanted to remove extra detail from the reflections in your scene to save you some render time. Well, that's what you would use. Shadow ray does something similar for shadows, diffuse does something similar for diffuse, glossy. This one is singular ray, actually has to do with how sharp the glossy will be. Reflection is pretty much what you would expect. In this case, it's actually going to be the exact opposite of the is camera ray. It will show you when something is the result of a reflection or if it's a direct view of the camera. Is transmission ray does the same thing with transmission. The ray length returns data based on how far light travels between each bounce, so if I pair that with a transmission, you'll see that it becomes darker the shorter the light bounce is. The ray depth gives you access to how many bounces a light ray currently has. This could be useful for things like optimizing glass, and the other depth outputs do the same thing, return the number of bounces with various different types of shading. Object info node. Location, as you might expect, tells you the location of the object, randomize UVs and things like that to avoid repetition. Color gives you the object's color. Object index gives you the pass index in the object panel. Material index gives you the material pass index down in the settings of the material. And random is probably the most fun because it'll give you a random value for each object, meaning you can give it random colors and things like that. Particle info. So the particles are numbered and the index gives you the number of the particle particle. The random output will give you a random per particle value. Age shows you how many frames the particle has been alive. Lifetime gives you the number of frames it will be alive. Location gives you a vector of where the particle is in space. Size gives you the size of the particle. The RGB node is pretty simple. It just returns a color value that you choose with this color wheel. The tangent node is great for creating a custom tangent for an anisotropic BSDF. Further customization can be made in the anisotropic BSDF, such as rotation and the amount and color. But with the tangent node, you can control how it's projected onto the surface, such as with a normal cylindrical projection, or you can actually use a UV map. The texture coordinate node helps you define where a texture should be placed on an object. The generated output is used when maybe you don't have UVs set up and you want something to be done quickly based on the size and shape of the object. The normal output can be used to determine which side of the object you're looking at. If you run it through a separate XYZ node, you'll be able to control it, say from the side, the top, or the other side. You could use this to swap between two different materials and say add snow to the top of your objects or things like that, or dust. But do remember that this is local space, not world space, so it's not going to change if you orbit it around. The UV output will control the texture based on the UV map you've created for the object. The object output is very interesting to me because you can use this eyedropper here to select something that you have in your scene, and then you can control the texture based on the rotation, the scale, and the position of that object that you chose. The window output is similar, except it uses the entire window and not just the camera. I really like this one, and I feel like there's definitely something to be made with this. The reflection output UV map lets you output the UVs of any map that you choose. It's especially useful if you have multiple UV maps on one object. Value node outputs just a value. As far as I can tell, it can be basically any value. The wireframe node gives you the wireframe of an object and allows you to control the size of how it appears on that object. Since we're working with material nodes, there's only one output node that we need to care about, and that is the material output. Essentially, this is the end product of all of the other nodes that you have in your setup. You can, of course, attach something into the surface output and use some sort of surface shader to control the way it looks. Alternatively, you can use a volume shader, which we'll get to later, and place that into the volume input. The displacement input is for when you want to use some bump or normal data. Now that we've got that out of the way, let's talk about all of the different shader nodes. The first is add shader. Essentially, it's going to just add any shader data on top of any other shader data. For example, if you add a diffuse and a glossy together, you could get a nice porcelain or ceramic material. We've talked about the anisotropic BSDF before when we talked about the tangent input. I think the best way to think about what this shader does is to think of the bottom of a kitchen pan. It's one of the only places I've seen this kind of effect going on, but it's a great way to bend the light around a certain point. Now, this is the diffuse BSDF. This used to be the default shader for Blender materials. And so now I think it's a good time to discuss what exactly a BSDF is. It's called a bidirectional scattering distribution function, and essentially what it's meant to do is calculate how light rays should interact with the surface. The diffuse BSDF does it much differently than something like a principled BSDF. This is now the default for Blender, but we'll get into that a little later. In the diffuse BSDF, we have a color input, a roughness input, and a normal input. The color, as you might expect, adjusts the color of the surface. The roughness adjusts how precisely light rays should be reflected off of the surface, and the normal input allows you to use something like a normal map. For most practical uses, the emission shader turns any surface into an emissive surface. You can use a color input to change the color or maybe make it some sort of texture, or you can use the strength to adjust how strong the emitted light should be. The glass shader also works how you might expect, turning your object into glass. The first parameter is the distribution function. These are the same options that you have with the glossy BSDF. Most users will not have to worry about these. Next, you have a roughness input, and this determines the sharpness of the refraction. Imagine it like this. If there's a sun or a light ray coming into the glass like this, with a roughness of 0, it's going to hit the surface and then bounce straight through. However, if the roughness is something like 1, it's going to hit the surface and then scatter throughout. That's kind of how you can imagine roughness. And as you can see, this is the result of all of that light scattering. The IOR is something that we call index of refraction. You see this option in a Fresnel node as well. It tells the light at what angle it should pass through. For instance, if you have an IOR of exactly 1, it will be pretty much a perfectly clear object because the rays are literally passing right through. The default is 1.45, but you can adjust this if for whatever reason you felt the need to. The hair BSDF is what most people used to use for hair simulations. You can of course adjust the color and all of that, however it has most recently been nearly replaced by the principled hair BSDF, similarly to how the diffuse BSDF is now to the principled BSDF. The holdout node is something that you don't hear talked about a lot. What if I told you that there's a Suzanne that is visible in this scene? Yeah, it's not visible. You can only see it if you turn the scene like this. That's right. What the holdout shader does is turn the object into what is essentially an alpha mask. So you could mask out other objects, you could do really whatever you want with this, and to make sure that it works, turn the film to transparent and the render properties, and that's pretty much what most people will use this for. The mix shader is used to mix two different shaders together. You've got this slider, which will determine which shader has more effect over the other. As you slide it towards the left, it will use the top shader more. As you slide it towards the right, it will use the bottom shader more. You can, of course, control this with any type of black and white data. One of my favorites is the Fresnel input node. If we plug that into a viewer, we can see exactly what that data looks like. And now you know about what IOR is, so you can change that to whatever's appropriate for your scene. The principled BSDF node is truly a gift. There are so many different options, it's almost impossible to talk about them all in detail without going far over time. As you might imagine, the base color is again the color of the surface. The subsurface has to do with subsurface scattering, which we will explain later as it has its own node actually. The metallic will adjust the metalness of the surface. Usually though, this should be 0 or 1, and you'll see if you use a metallic texture that those are usually very polar black and white. For the average user, specular means how much reflection is possible. For example, if I took the roughness all the way down, but the specular is at 0, we're still not going to see any reflections. However, once I turn the specular up, now we can see all those nice reflections. Roughness works similarly to how it does literally everywhere else. If you turn it down, the surface will be less rough and provide sharper light reflections, and conversely, when you turn it up, it will scatter more light, reducing the sharpness of the reflections. We've talked about anisotropic already. Sheen is used mostly for cloth-like materials, and it has to do with the way that the light interacts with the edges. Clear coat is going to add a nice glossy specular layer on top of everything else, and this is really useful if you're making anything that has to do with paint, specifically car paint or boat paint. Here again we have the index of refraction as well as a transmission slider that can turn your material into a glass-like object. We also have an emission input to turn your object into an emissive surface. I personally like to use the emission node over this emission input simply because I have more control over the strength of the emission in a more convenient way. With the alpha slider you can adjust the transparency of the object. And now we have the normal input, which you can use normal maps with, clear coat normal, which will adjust the normals of the clear coat, and then of course the tangent if you're working with the anisotropic. Here you can see some nice images that describe the way some of these settings work. You can find these images in the Blender documentation. The principled hair BSDF is pretty much what everyone uses for hair nowadays. As you can see on a basic hair particle system from a plane, you can see it looks incredible. Here we have the color parametrization, and you have three options here: direct coloring, melanin concentration, and absorption coefficient. And the direct coloring is probably the easiest for most people. You can pick pretty much any color, and it's going to try and choose the necessary absorption coefficient to make it work. If you want to take a little more technical approach to it, you can use melanin and melanin redness, and all of these melanin numbers mean something. So 0.25 melanin will be a very strong blonde color, while black hair would be a melanin level of 1. You can tint it certain colors with this, but the more melanin you have, the more difficult it will be to do this. The next one is absorption coefficient, mostly for technical users. I don't think many of you will be using this, but you can read more about it on the Blender documentation. Next is the principled volume node. You can use this for models, or you can use this for things like smoke. The refraction BSDF is used, as you might expect, for refractions, but it's not meant to be used on its own. You should be combining it with things like glossy and transparent shaders if you want to, for example, create a custom glass setup. This next one is subsurface scattering. Essentially, light doesn't go straight through or bounce straight off. It will bounce around internally before leaving. It's useful for things like wax or skin or marble. The Toon BSDF is used to create cartoon light effects. Keep in mind that this is not what you're looking for if you're looking to create some sort of cell shaded effect. Translucent BSDF for most users simply increases the ability to see through some of your objects. The transparent BSDF, on the other hand, allows you to see through them entirely. The Velvet BSDF is used for fabric-based reflections, however it's not very useful on its own. You'll want to combine it with other shaders. Volume absorption and volume scatter are different types of volume shaders. Let's talk about the different texture nodes. First, we have the brick texture. This is a fun one. You can adjust the size of the mortar in between the bricks and the size of the bricks themselves. You can of course adjust the color of all of this, and with all of these parameters, you can make some pretty cool brick-shaped textures. Next up is the checker texture. You can adjust the scale and the colors with this one. Next up is the environment texture. For some reason, it's available in the shader textures, but I've never ever seen this one used except in a world output. It's what you'll use to introduce an HDRI or something like that. Next up is a gradient texture. You've got all these different types of gradients to use. I tend to use this one with a converter map node, and if you play with the value in here, you can adjust the position of the gradient pretty easily, and you can even add in another one and make it and turn it to multiply, and then you can adjust the fall off pretty easily as well. An IES texture is a special kind of texture that uses a special type of file type that I've never even used before, but it's a special data type used to mimic real-world lights. If you happen to have an IES texture, you would switch this to external and then find that texture wherever it is. Now the next one is the ever popular image texture. Image textures can be mapped onto surfaces, and I cannot stress how useful they are. If you want to instead use a video texture, make sure that you change this parameter from single image to movie, and then you've got to choose how many frames you want it to play, which frame it should start on. If you want the movie to repeat itself, you can just choose cyclic, and make sure you check auto refresh to be able to preview it. Now the next one to care about is color space. If you're working with image textures and you happen to be using a roughness map, a specular map, a metallic map, and all sorts of maps, the base color and if you have an ambient occlusion texture are the only ones that you should have the color space set to sRGB. Otherwise, you'll need to make sure to set it to non-color, because that will tell the engine that you're not actually just trying to output color data, it's being used for something else, because otherwise you can get some really weird results, especially with the normal maps. So make sure to change that. For the magic texture, I was going to make a clever joke, but I think I'm just going to play with some settings and just let you figure it out. I've always seen the Musgrave texture as a bit of a glorified noise texture. Here you can see some examples of what you're able to pull off using a Musgrave texture. There's 5 different noise types here. It's got some pretty incredible variety. The noise texture, however, is an easier noise texture. There's 3 main things to worry about. That is scale, detail, and distortion. And the good news is those all do pretty much exactly what you would expect them to. Sky texture is again one of those things that is mostly only used for world outputs, so you probably don't need to worry about it when you see it in the node menus. The Voronoi texture has a specific noise pattern that a lot of people remember it for. However, it's possible to generate a lot of different ones, as you can see in these diagrams. Here's some really cool uses of the Voronoi texture. Next up is the wave texture. I use either bands or rings based on whether I'm using a curved object. You of course have the option to adjust the scale, the distortion, that's a cool one, and the detail scale. The white noise texture only returns a single value based on any kind of vector input. You know, it reminds me a lot of the white noise that you might see on a blank channel or something like that. Starting us off with the color nodes is the brightness and contrast node. Now this pretty much does exactly what you might think it does. The brightness slider will adjust the brightness of the color data you're feeding it, and the contrast data will increase or decrease the contrast. This is useful both in textures and in compositing, or pretty much anything else that involves color data. Now, next up is the gamma node. And if you've messed around with this before, you've probably noticed that it also has to do with the luminance. One good way to think about it is an exponential version of brightness. Now, next up we have the HSV node that stands for hue, saturation, and value. All of these values have the same meaning as they would in any color correction workflow. The hue adjusting the color or hue of the image, the saturation having to do with the potency of that color, and the value having to do with the brightness of that texture. This factor slider adjusts how effective your changes will be on the output, and that's really all there is to know about it. The invert node is made to, well, invert any color or black and white data. The mix RGB node, which can be found under color, is useful for combining multiple different images or textures. For instance, here I've overlaid a noise texture over a brick texture. As you can see, there are multiple different blending modes that are available. The ones that I use most often are mix, which literally just blends the two together, and you can use the factor slider to adjust which has more control. You can see a lot of the technical definitions of these blend modes by going to the GIMP documentation. I will link this in the description for you. The light fall off node is a bit tricky to describe. I've only seen it used with lamps. Now I know this isn't a material necessarily, but it's pretty cool. So essentially the light fall off will give you the light fall off data here. If you try to put a gradient or something and attach it to the emission of a light, it's not really going to do anything at first. But if you use the light fall off data, and you may need to do some manipulation with the data, we'll get to these converter nodes in a bit, but let's say you use the multiply node, and you're going to need to bring it down to a value of 0.2, throw in the linear light fall off data in there. These are the different ways that light is calculated in cycles, and this only works in cycles, by the way. I'm going to bring the strength down to 1, and then bring the multiply value into the color ramp. And well, here you can see you can make really cool customized stylized light effects. And finally, we have RGB curves for color correction. You do of course have access to the RGB channels, as well as the ability to reset the curve under this arrow menu. Moving on to the vector nodes, we're starting out with the bump node. Now essentially what the bump node will do is create a modified normal output based on the input of a height map. Now, you can use really anything here. I'm just using a black and white output from a brick texture mapped based on the camera. The strength is pretty self-explanatory, but the distance can be thought of as sort of a multiplier. Now, the vector curves node works very similarly to the RGB curves node, except with vector data. Now, I haven't seen this used very often in materials. In fact, it's most often used in the compositor when working with the vector blur effect, which can be used as a faster, less expensive motion blur. But you can use these curves to adjust the angle of such an effect and some other things. There are 3 curves in here. There's the X, the Y, and the Z, and you can manipulate them all by clicking and dragging to create new points on the curve, as well as using this arrow drop-down menu if you would like to do something such as reset the curve. Now for the displacement node, I wanted to bring you to a material that I worked on a while ago. Now this node setup was not very well organized necessarily, but I think it's a fun example for how the displacement works. So essentially what the displacement will do is take a height map and displace the surface of an object along the normals of that object for more detail. As you can see, unlike a bump map here, the outline of this object, the silhouette, is actually detailed. This is real geometry that's going on here. And that is because this is a very finely subdivided model. You need a lot of geometry to be able to have something like this work. I have a subdivision surface modifier on here that is resulting in over 63,000 vertices, and it's not even a whole sphere, it's just the half of one. So should you use this displacement? Maybe. If you're doing a lot of close-ups and you really need that fine detail, this could be worth it, especially in organic-based materials. This looks incredible. But if you're planning on using this in other places, you'll definitely want to simplify the geometry. Now, finally, let's talk about this mapping node. As you can see, we've got a location, a rotation, and a scale input in here. Now, these all can be controlled by other vectors, or you can adjust the values manually. For example, with the location, we can adjust the position of the texture on the model. With the rotation, we can do something similar with the rotation, and as you might expect, the scale will adjust the scale on the object. Converter nodes do exactly what the name would suggest, converting one type of thing into another. Let's start with the black body node. Now, this essentially can convert a temperature into a color output. Here you can see some examples of the colors that are emitted based on their natural frequencies. Next up, we have the clamp node. I'm using a Voronoi texture to illustrate this. Black and white values tend to go from 0 to 1, 0 being entirely black and 1 being entirely white. Now with the clamp node, you can set minimum and maximum values for these things. So if I believe that the darks are much too dark, I can set a minimum dark level and it will clamp out some of those darker areas. Same with the maximum. If some areas are too bright, all I need to do is decrease the maximum and it will gray out all of those light areas. Next up is the color ramp node, and if I had to pick a favorite node out of every single node there is, it would probably be this one. It's just such a versatile node. It's just incredible. So there's many uses for it. One of them is colorizing images. You can use a color wheel to select a color and use that as a substitute for whatever you're inputting. So in this case, it's taking the black and white and essentially just replacing black values with red values. I can do the same with the white side. I could turn that to blue. Really, there's infinite possibilities here. One of my favorite things about the color ramp node is that you can change the interpolation from ease to cardinal to linear to B-spline, and one of my favorites, constant. This means the data will have no fall off at all, and you can generate some insanely cool effects with this, especially if you're trying to work with cell shading or something like that. Next up, we've got the separate and combine nodes. Now, the first of these sets are the separate and combine RGB. Now, essentially what this will do is take color data and separate it into the red, green, and blue channels, and then the combine RGB node will combine all of them together and then output the color. So why would this be useful? Well, it pretty much allows you to adjust the individual channels, and that could be really useful for a variety of reasons. Next up, we have the separate XYZ, which will turn a vector input into its separate X, Y, and Z values. We already talked about how those are significant. And then, of course, the combine XYZ will take all of those and then output another vector. And then finally, the separate HSV. Yes, this is hue saturation value that you are separating. If you'd like to adjust any of those parameters individually, it's all up to you. You can think of the map range as kind of readjusting the minimum and maximum. So if I input this Voronoi texture here, which tends to output, as we said before, values from 0 to 1, here we can readjust it. I mean, you could make the minimum -1 and the maximum 2 if you wanted. Now, this is especially useful when what you want to output is not within the range of 0 or 1, such as particle age or things like that. Next up, we have probably the most intricate individual node, and that is the math node. And it's probably the most complicated because, well, you have all of these parameters down here, but the main one is this box. And if you open that, you can see that you have so many operations that are ready to use here. They're all mathematical and used for conversion of value. Now, I've had to use add, multiply, less than, greater than, and maybe a couple of others from time to time, but the average user may not find the need to use this very often. So I'll provide you with a link to the Blender documentation, which in turn has links to approved resources on each of these functions. Next up, we have the RGB to black and white node, and that does exactly what you think it does. It takes in a color input and then outputs it as black and white. Now, I almost didn't include this one because it's Eevee exclusive, but it's shader to RGB. And it's actually pretty cool what it does. And essentially what it does is it takes shader data and turns it into RGB data. And that includes the lighting, which is awesome. And so with that, you can actually take it and run it through a color ramp node, for example. And then what did I tell you earlier about the constant? And now you can do things like really nice cell shading and whatever other creative effects you come up with this. Next, we have the vector math node, and it's essentially just like the math node, except instead of working with single values, you're working with sets of 3 values or vectors. Now, there's not as many operations here, but the description of each of these is on the Blender documentation, so again, I'll link that in the description. And finally, for converters, the wavelength node is used to create a color out of a simple wavelength number. I imagine this makes it pretty easy to animate so you can finally have your RGB gaming cube. And finally, we have everything that I would consider miscellaneous. The first of which is the script node, and this is simply used to grab Python scripts. The make group option under group is for when you find something that's particularly groundbreaking. You just go to group and choose make group to create group inputs and outputs. You can rename these group inputs by pressing the N key, and then you can set those up to go where they need to be. And then once you're ready and you've figured it all out, then you press this arrow key. Now you've got your custom node all ready to use. It outputs as a shader in this case. And if you need to add it again, you can go under group and choose which group you want. Really nifty for organization. Speaking of organization, we've got layout nodes. The first one is a frame, and that's really useful for organization, as you can see here. If you want to call it something other than frame, make sure to just type in the label box something other than frame. And since we were speaking of organization, we've got this. Essentially what this thing will do is create a subdivision in the node connection. You right click to drag it around, and now you can reroute your node noodles all over the place. And well guys, that does it for the explanation of all of the nodes. So if I missed something, or if you have something that you want to add, feel free to add it as a comment, and I'll be sure to add it to the description or pin it as a comment if it's something that is incredibly important. And with that, I won't waste any more of your time. This was a long video already. So happy blending everyone, and I'll see you in the next video.